Are you struggling to find the derivative of exponential functions? Do you give up and go to Calc chat anytime you see the letters log? If so, it might be time to ask your math teacher about logarithmic differentiation. The main active ingredient in logarithmic differentiation is this, the derivative of natural log of x. If you take the derivative of any natural log function, all you need to do is raise that function to the power of -1, making sure to apply the chain rule wherever necessary. The derivative of natural log can also be used to find the derivative of other logarithmic functions with bases other than e. All you need is the change of base formula. Once you've converted the logarithm into two natural logs, you're ready to take the derivative. Assuming that b is a function of x and a is a constant, the derivative will work out to 1 over the natural log of a times 1 over b times the derivative of b. Let's look at an example. Say I'm walking along a straight path, and my position in meters from my starting point can be modeled by this function, where t is time in seconds. If I want to find my velocity at any point along this path, I'll need to take the derivative of that function. To do this, I'll use the rule I just established to find the derivative of a logarithmic function and apply it to this equation. Since the function b in this case is t plus 1, the derivative of b, db dx, is just 1, so we can leave it out of the equation. That leaves us with the velocity function of 1 over natural log of 2 times 1 over t plus 1. But what if you need to take the derivative of an exponential function? Say we need to take the derivative of this function. Now you might be tempted to use the power rule here, but take a closer look at the exponent. When the exponent is a function and not a constant, you can't use the power rule. So instead, we have to use logarithmic differentiation. Start by taking the natural log of both sides of the equation. This is where logarithmic differentiation gets its name. Next, move the x in the exponent in front of the natural log, leaving you with natural log of y equals x natural log of x. Now you can take the derivative. On the left, that'll get you 1 over y times dy dx, in accordance with the chain rule. And on the right, you can use the product rule to get x times 1 over x plus 1 times natural log of x. Now, you can simplify the x times 1 over x into just x over x, which will get you 1. Then, multiply both sides of the equation by y, leaving you with dy dx equals y times 1 plus natural log of x. If you substitute in x to the x for y, that'll leave you with dy dx equals x to the x times 1 plus natural log of x. Thanks to logarithmic differentiation, you've found the derivative. Ask your math teacher about logarithmic differentiation today.